character, whether it be cartoon or all Adam Sandler movies, except for that Cobbler movie. That was dumb.
I like Chevy Chase movies.
Oh, man. Oh no! And you fell right, man. All right, up top, whenever I simplify, I get 6x. Yes, I agree. Because it's just algebra. It's just 2x to the third minus 2. Watch these signs up top. That's where most people mess up if you mess up. Over, it's not 2x squared, it is 4x squared. Make sure you square the coefficient there as well. So now, if I find, whose birthday is it? All right, if I do the derivative at 1, I get 4 times 1 cubed minus 2 over 4 times 1 squared, which is 4 minus 2 would be 2. You have to distribute that minus sign.
What do you mean? Oh, you gotta, yeah.
So the gray ones are the ones.
Yes, gray or non-calculator. So this would be non-calculator. So now, remember that's not all. What did I just find? Slope of the tan line at y equals 1. So now I need a point because I need a point and a slope. So I'm going to find y of 1. I'm going to plug that in to the original equation, right? So 1 cubed plus 1 over 2 times 1. You can. So this point is 1, 1. So write the equation of a line given a slope of 1/2 and a point 1, 1. It is.
We're just finding slope different ways.
What was the difference between you plugged in one and the first one? Because
One's the derivative slope.
This gives me slope because it's derivative. This gives me just the point, so I have a point and slope. This is the original. This is the derivative. Yes, Aaliyah. This is the homework last night.
Oh, my bad.
Other questions about your homework? Say that again, 30? 38. 38, 39, and 40. Okay. $38. Find the tangents to the curve y equals x cubed plus x at the point where the slope is 4. And actually, so this is the slope. So this just gives it to you a little bit different. What is the smallest slope of the curve? At what value of x does the curve have this slope? So, thank you. Excuse me. That's exactly right. Because what are you, tell me what you're doing. Tell me what you're doing. You need to set the derivative equal to 4 to find out where that happens. So 4 equals 3x squared plus 1. Subtract 1. That is exactly right. And then what's the next question? So that's the points where the slope is 4. What is the smallest slope of the curve? Okay, so let's think about this. All right, this is where slope of tan is 4. If I want to know, and you got to think about this. This is a big question. Where is the slope the smallest?
At the max, right?
without specific values.
At 0.
What's 0?
At horizontal.
When the limit is 0.
What is the smallest? Why does it always do that? What is the smallest slope, and where does this happen? All right, how do I find slope, first of all? Let's stop thinking about this. This is just where the slope is for. Let's don't think about that. Let's think about if this is my equation, how do I find the slope? We're talking about the slope of the curve. So the slope of the curve would be the derivative, right? Are y'all with me? So the derivative is 3x squared plus 1. Now think about this. If this represents my slope.
Oh, you just do the derivative a bunch of times, right?
If this represents my slope, how do I find where that is the smallest?
0.00.
Could it be negative? That's smaller than 0.
Just tell us. Just tell us. We don't know. Just tell us.
Throw darts at the wall.
Do you know?
Yes. Let me ask you this. I just wanted to make sure I was interpreting the question right, because y'all are not getting what I'm putting out there, so I want to make sure. But I did understand correctly. No, what I'm putting out. Okay. I want to know the smallest value that this can ever be. What is this?
That's the derivative. I think
It is okay. What else is that? Go back to algebra 2. It's a parabola. It's a minimum.
I said that already. That was like the first thing I said.
I'm sorry.
No, you said maximum.
I said, is it the maximum? Oh, wait, the minimum.
And what is a minimum on a parabola?
The vertex.
The vertex. Right? This is this parabola, right? So the minimum value on a parabola happens at the vertex. So now my question is, how do I find the vertex of 3x squared plus 1? You don't even have to do that. It's in standard form. How do you find the vertex?
I don't know, bro.
Oh, you go.
Do y'all remember that? Clearly you don't. Okay. So where is the vertex? And if you didn't remember that, I've got a parent graph, right? Here's my parent graph. It's been stretched vertically by 3. That's not doing anything. That thing hadn't moved left, fan. The vertical stretch is just going to do this to it, right? And then it moves up 1. So even if you didn't remember the way to find a vertex, looking at it that way by transformations, I know that vertex is still sitting on the axis, right?
The smallest slope is 0.1.
So the smallest slope happens when x is 0. What is that slope?
If you plug it into the vertex.
These nuts?
There is no B. There is no B.
So it's 0. Okay, so I plugged it into this equation because that equation is the equation for the slope, right?
How did you know plug in 1?
I didn't plug in 1, I plugged in 0. Because this point is 0, 1. The vertex, which is the smallest, it said was the smallest value. I think y'all are overthinking this. You know, y'all, I think y'all have just been in so many classes together for so long. Y'all are like brothers and sisters that fight.
We're were actually on a trip one time.
Okay.
Lady thought she was like, we were like arguing in the elevator.
Because I broke his mask.
She was like,
And my mom played a lot of it.
All right.
that was a cool story.
About what? About this? Okay, so look, at the end of the day, the b is 0 because it's ax squared plus bx plus c. What did I tell you was going to happen? It's the algebra. It's always the algebra. I'm sorry. Okay, man. Thank you very much. All right. So the derivative is always the slope. That's what you have to remember. So if I want to know where is the slope the smallest, I want to know where is the derivative the smallest. And since the derivative is a quadratic, that's an easy minimum. Find that minimum and you have found where, because the minimum of the derivative is 0, 1. So that tells me that the slope has a minimum value of 1 at x equals 0. We're talking about this in pre-cal a lot, that whenever you say the value of a function, you're always talking about the y value. The function's value is its y value. Watermelon. Yes. The answer is a minimum. Well, so it asks you two things. What's the smallest slope of the curve? The smallest slope of the curve is 1. And at what value of x does the curve have this slope? 0.
So basically what you have to do is you have to get the derivative, right? And you have to plug 0 into the derivative. And that's going to give you 0. So that's your slope. Now that we have done this, we know that the y-intercept is at 0, 1.
Vertex. It is the y-intercept, but it's the vertex. It's really what we were looking for. We weren't looking for.
It just happened.
Yeah. 39 is very similar. The difference is on 39 they say find the points on the curve, and they give you this equation. And I'm probably gonna help you set it up and then leave you to it. Did you? Where the tangent is parallel to the x-axis. So parallel means same slope. That's exactly right. And what's the slope of the x-axis? 0. So you're looking at where this is going to equal 0. Okay, you'll end up with a quadratic that you'll solve for 0. You want me to do it real quick? All right, so why the derivative is, tell me the derivative. Quick. Yes. Thank you. If I make this equal to 0 and I solve it, I can divide everybody by 6. This one was way easier. I divided both sides by 6. Sure. So I have, it says to find the points. Well, the points happen when x is 2 and x is -1, but to find the actual points, I would need to do y of 2 and y of -1. To the original equation. Correct.
So, can I?
Hello.
I'm related to me.
What? All right. I'll let you do that, but you should get 27 and 0. 0 and 27 like that. Let's see. What else? That was 39. Anything else from your homework? All right. Say again. Number 40. Find the x and y intercepts of the line that is tangent to the curve y equals x cubed at the point -2 and -8. X and y intercepts. That's right. Okay, so the first thing I'm going to do is find the equation of the tan line, because to find the x and y intercepts of the tan line, I need the tan line. All right, so yes. What's the derivative? 3x squared. Easy peasy derivative, yes? What is the, all right, what's the slope at -2? I have a slope, I have a point. Let's write the equation of the tan line. Plus, right? They gave us that point. That's why it was non-calculator. They gave us a lot of this stuff.
Pluses because they're both negatives.
Yes.
How'd you know how to write it?
You can witchcraft, Andrew.
Point slope.
I'm gonna show you my answer. 1 second. Stop class.
What happens at x-intercepts? What happens at y-intercepts? So I'm going to take this equation. So 8 equals 12 times x plus 2. If you want to divide first, or if you want to distribute and then solve, it doesn't really matter. Subtract 24 was 20. What's 8 minus 24? 16. Divide by 12. Bless you. That's the x-intercept. What are y'all back here doing? More derivatives, more derivative rules. I'm gonna pause, give y'all just a second to talk it out, because y'all got lots to say today before we go on with today's stuff. And Newton's serpentine. Doesn't that sound like fun? Yeah. Notes is loose. I'm working through some of the homework problems. You know, they get increasingly more difficult as we go. So this is the last set, which are mostly word problems. This is the last day we'll do. On Monday, we will practice some 3-1 through 3-3 boys. And then on Tuesday, we will take our 3-1 through 3-3 quiz, which will probably take most of the class period. I'm thinking around a half a test weight, maybe. I don't know. 69-point quiz. Oh no, yesterday's was a 25-point quiz for them. I'll tell y'all the story about that in just a second. Find the tangents to this at the origin. I think y'all can do this one on your own.
Would that be an axis slope?
What's the origin? What? I think I'm gonna leave this one to you tonight and go on to a little bit harder one. So it asks for the tangents at those 2 points. So you're just finding y prime of 0 and y prime of 1. And then writing the equation of the line, given the slope and the point, the slope and the point.
Why 0?
Because it said, let me read it to you again. Find the tangent to Newton's serpentine, y equals 4x over x squared plus 1, at the origin and at the point 1, 2. So you're looking for two different equations. Okay. Yes. When in doubt, find the derivative. No, I'm just kidding. But yes, you do find the derivative here. All right. Let me look at 46 instead, because this one's tough. I meant with your homework.
Wait, I don't know what to do though. I got to.
Oh, okay. So let's do the derivative. Quotient rule, yes. Derivative of the top. That's, yep, 4 times the bottom minus the top times derivative of the bottom. Yes, right, you're subtracting in order of subtraction matters. Over the bottom squared. I'm not even going to simplify this right now. I'm just going to go ahead and plug in, because I have a 0. I'm going to do 4 times 0 plus 1 is 1, minus 0, 0 is going to be 0, over 0 plus 1 squared would be.
I was right. I was right, I guess, and I was right. How did I?
What does that tell me? At 0, the slope of the tan line is 4.
I guess.
So Van, what's the equation of the tan line?
Y minus 4.
It's point slope. Yeah.
Keep going. Mm-hmm. So cleaned up. Tan line at the origin of this function is 4x. Whatever this function is doing, 4x, kind of steep like that, that's the tan line there at the origin. It's fine. And then at 1, same song, different dance, huh? Yeah. Derivative at 1, 4 times 1 squared plus 1 would be dose, minus 4 times 2 over, does it even matter? Doesn't really matter, because up top is what? What does that tell me?
I have 1 and 0.
Because it's 0. Good job. Look at you. Did everybody else get that? The slope is 0. It's a horizontal tangent, which means that's a maximum or minimum of the function. Oh yeah, I'm so proud. That's 2 days in a row. All right, so what's the equation of the tan line at this point? Y minus, what was the original point? 1, 2. So y minus 2. So what's the equation of line? Makes sense. It's a horizontal line. Yay or nay? Yay. Another. Ooh. This is so typical. If you have, do y'all have your book? Let's call this alphabet soup because of all the variables in here. It's on page 130. It's number 46. I just want you to see how this is set up. Do you? Is it? What? What'd you call it? Pennert? 46. If gas in a cylinder is maintained at a constant temperature T, the pressure P is related to the volume V by a formula of the form P equals nRT over V minus NB minus AN squared over big V squared. And the key at the bottom says A, B, N, and R are constants. And then you have this nice little drawing down there that I'm not going to try to draw for you. That's why I told you to look. I didn't know y'all had seen this before that. So okay, so constant. I'm going to just do this. Constant, 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 constant. Why is that important? Well, it asked me to find. There you go. Good job, Nick. The derivative is 0 at the constant, right? If that's just a number, the derivative of constant is 0. And it asked me to find dp dv. What the heck does that mean? The derivative of p with respect to v. That's exactly right. What we have been doing, we have an equation equals x, and we find dy dx, which is the derivative of y with respect to x. Now we're going to find the derivative of p with respect to v. V is the variable that I'm finding the derivative. That's the one I'm changing things on. You could look at this like y equals what did I say? dp dv x and x. Is RT together? Is that those are two different? Oh, T is also a constant because it says a constant temperature in the beginning of the problem. So the only thing that varies there is V. Okay, so you have to look at everything else as a constant. So here we go. Let me just rewrite because I've marked all over it. Let me rewrite P equals nRT over V minus NB minus, what was that originally? A n squared over V squared. Let's do the derivative. Well, let's look at pieces because I can do the individual pieces, right? Derivative rules let me do that. They let me split this up. Derivative of first and derivative of second, as long as I'm subtracting. How could I find the derivative of this if the only variable in there is v?
You have to do the quotient rule.
I'm going to do the quotient rule. Let's do the quotient rule and show you what happens. All right. dp dv, and you might see that once we do this, we could have done it a little bit easier way, but that's okay. We're going to do it this way. Start with A and N are constants. That's right. So if I do the derivative of the top with respect to V, and those are all constants, what is that derivative? So I have 0 times the bottom minus the top. What's the derivative of the bottom? 1. It's 1. Why would it be 1? This is, if this were x, if you had x minus, and then you had constants, I don't know, 3 pi, the derivative of that would just be 1. Because, are y'all with me? All over the bottom squared, but now we have to do the same thing for the second fraction. So derivative of the top, what's derivative of the top of that? 0 times the bottom minus top times derivative of the bottom is what? 2v. Because these are both constants, and the derivative of a constant is 0. That's why I said this was the key here to this problem. It's not as intimidating as it looks if you realize what all is constant here, because derivative of a constant is 0, and it makes life so much easier. And then square the bottom. These are those problems you get through the whole thing and you realize you've written like one number and you go. All right, so let's clean it up a little bit. What happens on the top of the first fraction? Negative nRT. And the bottom, I'm going to leave just this way. It's a big deal. Minus. So I'm going to make this, instead of minus negative, I'm going to go ahead and do plus here, since the whole top is negative there. So you said it's what? 2v an squared. Remember that an squared is a constant. 2 vans. Yes. So you treat everything as a constant except for the variable that we are deriving with respect to, which is the v, because it's what changes. It is a lot. This one's tough, just because of variables. But that's it. That's the answer. That's it. We could actually take a v out here if we wanted to clean it up a little bit. But we like it to say van. Just one. 911. It's an emergency. All right, we're getting increasingly harder.
No, well, why would you say that?
Well, this will be the last one. Definitely the hardest too, so. The members of the Blue Boar Society. We're almost done. This is the last one. This one's in your homework, and I know it's just you're gonna get up to it, and you're gonna go, nope. I'm just gonna ask Miss McGee about that one. Yes, 48 is on our homework. I was going to do 49 with you. It's a geometry type problem, but it talks about the circle with a radius and how it changes with respect to. But I'm going to leave that one to you to see if you can figure out, but I'm going to look at number 52. All right. The members of the Blue Boar Society always divide the pavilion rental fee for their picnics equally among the members. Currently, there are 65 members. And the pavilion rents for $250. No, it's a whole pavilion, a pavilion like a building. The pavilion cost is increasing at a rate. When I see the rate, I'm automatically thinking what? Some type of slope, whether that's A rock or I rock. At a rate of $10 per year, while the Blue Boar membership is increasing at a rate of 6 members per year. What is the current instantaneous rate of change in each member's share of the pavilion rental fee? Answer in appropriate units of measure. In other words, how much they pay per year based on how much it increases and how much how many their membership decrease or increases. Are they paying more or less per year, and how much more or less right now are they paying? What's the rate of change? So, you know how you can find the average rate of change, but how can I find I need an equation. I definitely need an equation. We need some variables. Yes. You want to use X and Y since that's what we're used to using? Okay, so X and Y. If I'm looking for the rate of change of the rental fee, I'm used to doing which variable in my rate of change one like that.
H.
Which one, in other words, which should be which? Does it matter?
It does matter. Because it matters to me. 65 is X.
You want to do the 65 as X. You want to do this one as Y. Okay. What's the instantaneous rate of change currently?
We don't know when.
What is the current rate of change in the member's share? So the okay, but we can find an equation for the instantaneous rate of change. Oh, gosh. What shall we do? How many members per year? 65 members. Ooh, now we've got years. What should we do?
What are you asking? Is there a right answer? For the variable?
Let me ask you this. What if I let my variable be the number of years? Could you do that? All right, let's take this up. Let's take this off the table. Let's let my variable be the number of years. And let's say, so my members are 65 plus 6x. Do you agree with that? How about the cost? It's 250 plus 10x. I have now written it in the form of just one variable, which is easy to take a derivative of. Do you agree? Okay, so if this is my member, this is my cost, right? How do I find the cost per member? Okay, so 65 plus 6x, that's my number of members.
Over D squared minus X.
Derivative of the top times the bottom minus the top times derivative of the bottom. Now look, it says right now, it says that right now there are 65 members and it rents for $250, and it says what's the current rate of change? I would do 0 for X, right? That would be a lot of room for error if I did that. Especially if I'm using a number like 0 or 1. What do you get if you do 0? If you do the derivative at X equals 0, so current, because that was my current information. That would be 6 times 250 minus, why does it keep doing that? It's some garbage. No. That just says the derivative at X equals 0. That's not what we're supposed to get. Did we do it right? What happens if we do put 1 in?
I gave her a pen, and she got me $100 for it. It was kind of a figure of five.
No. You'll look over the 5 a.m. series outside. He wants me to do it. He's like, I thought you wanted it. Figure out all the things like it was. And they're the other side. I think their wages are
I stand by my answer.
What was your answer?